Well, hello. How's everyone doing today? Hey, Yomagan. Hey, Jose. Bit of toe tapping action going on there. Yes. No socks today. Yeah, I mean, a little birdie told me that if you want the people to come, if you want them to come to your stream, you need to show a little bit of skin. And apparently people like feet. I don't get it myself, but you know what? I'm willing to risk it for my art. I assume no timer today. Nope, no timer today. We're actually done with the giveaways. The last giveaway was last stream. I'm double-checked it earlier. Yeah, we're done with all the giveaways for filament, at least. We're still going to give away the 1.6, but we'll do that once it's finished. Speaking of getting it finished, we've got some stock. We've got stock. Can I start a timer just for my sake then? Yes, of course you can. Of course you can. All right. I know Nero's streaming right now, so there's probably going to be a load of people over there as well. But if you are in stream, if this is your first time, or you're just coming to watch the support, make yourselves known. It's always nicer when I've got people to converse with on stream. But today is going to be a bit of a weird one because I'm going to be muted half the time. Well, kind of half the time. We're actually going to be doing some milling. It is... What time is it? It's 9 o'clock at night. I have neighbors downstairs. But let's do it. We can do it. We'll be fine. We'll be fine. We'll be fine. Yeah, so I've made a couple of upgrades since last stream to the actual setup. So now, look at that. Look at that. It's not the best camera in the world, but at least there's a camera inside Casa now. 5-minute timer for some reason. Go, go, go. But we have a camera inside Casa now, so I can actually show you some milling. I have tested it as well. I don't know why we had so many EMI issues. EMI? EMF? EMI. Whatever. Last time, I think it was mostly because it was on the same power strip, so the Casa was on the same power strip that the camera was on, and I think it was just power issues. I don't think it was necessarily leakage issues or anything like that. There's no feet in this. The quality of the camera isn't critical. Oh, yeah, that was the old webcam. So that was the one I used to have on the table. We've upgraded to the camera that I was using last time as our, not webcam, as the table cam. So we've got decent camera now, so I can actually show you things in a little bit higher definition too. Lots of upgrades going around. Lots of upgrades. Why am I doing a bunch of milling at 9 o'clock at night? Because I've had a really shit day. With trying to get a bunch of machines to work. I've kind of had to abandon the tool changer project, and I'm gonna move over to the way Bright's been doing it, because you know what, his method is actually better than mine. I just wanted to see if I could do it, so we're gonna revisit the tool changer another time. Probably change some stuff around, because the one that Bright uses is an ER20 one, and we're going to be using an ER16 one, which is the one that majority of people are going to use. So I'm just going to convert the one that I have to be the same style as the one that Bright's been using. But anyway, I don't want that. We've got some milling to do. I haven't prepared anything. You know what? We'll do it like this instead. I haven't prepared anything. So we're going to go from scratch, and we can talk some strategies as well. So this... Yeah. If you look down the bottom left? Yeah. No, bottom right. It's my bottom left. Probably your bottom left too. So this is the plate that we did already. So that's the one that's actually attached to the spindle mount now, over here. So that one we did off camera. We're going to do the other plate, the one that actually attaches to the column itself, and all the carriages and things like that, which is this one over here. Now this one's a little bit trickier because the last one could be done in 2 operations. It's really easy. It was just a bunch of holes and then facing on the other side. There's actually features on the back of this plate that we need to make sure are in the correct position. So I'm going to talk you through kind of how I would go about it. It doesn't need to be the most precise thing in the world, mind you, but it needs to be close enough. All these holes are oversized anyway, and there's a lot of tolerance built into the actual design, so we don't need to worry about it. But first things first, I'm just going to copy this over into a new workspace. Paste new. Now, because it's new workspace, I don't need to worry about the parameters or any timelines. So I'm just going to get rid of the timeline because it makes it run a little bit quicker. Delete design history, yeah. I'm just going to get rid of that because we don't need it. It's not part of the process. So what we're going to do... Time is up. Cool.
Workshop air quality return to nominal levels.
Thank you.
Filters off.
Thank you, Alexa. Yeah. Yeah, I'm in a mood to destroy things today, but in a good way. In a good way. I've also one good thing did happen. I finally managed to break 2,000 millimeters a minute on this thing with a decent amount of torque. So that should be fast enough to be able to run 3-flute tooling. 3-flute tooling. So we're going to try some 3-flute stuff today. And if you're in the UK and you need 3-flute stuff, or if you're in Europe and you need 3-flute tools, or just tooling in general, DMS, well, they're not sponsoring it, but DMS does do tooling. You decide what to do with that. Fair enough. Fair enough. It looks like we've got a few more people joining stream. If you're just joining stream, say hi. Oh, perfect timing. Hi, Thomas. Say hi. It's always easier and nicer when I got lots of people to talk to. Hey, Joe and Joe. Oh, Island Tinker's here. Hot 3F action. Oh, yeah. Yes. I finally get to use my 8mm cutters as well. So we're going to probably start with some conservative cuts on this boy. Nothing more than like 1 millimeter deep. But we'll listen out. No, I'll listen out. I don't want to deafen you guys when we're actually doing any cutting. So I'll listen out to see if it's any good. Yeah. So the stock we are using today is 10mm tooling plate. The nice thing about tooling plate is that it's Blanchard ground. So it's two basically big disc sanders that are pressed up against each other from either side. And it brings it to a really, really flat state and parallel state. It's not the most flat thing in the world, but it does mean that we don't need to do any surfacing cuts. We will be doing a surfacing cut, but we'll be doing it on the other side. And that's mostly just to bring it into thickness. But it's only going to be 0.6 mil that we need to face off the back of it. You can also probably just get away with not doing that 0.6. If you don't want to do that 0.6 and you just want to keep it, 10mm, just modify your part. It's not that big of a deal. I'm here listening but typing. Might be a bit delayed as I'm packing for Rapid TCT. Nice. What actually gets shown at Rapid TCT? Obviously, I've only ever heard of Rapid from the 3D printer side of things. I've only seen Nero and a bunch of that lot go. There's obviously more tech at Rapid than just 3D printers. I guess there's like industrial. Is Rapid an industrial show, or is it more like a Smurfy type show? I'm guessing it's more industrial. I really should go one day. I think Dave might be going, or he has gone in the past. Right. Here we go. Look at, just before I ruin it with all the smudges, look at that. Look at that. You can see your face in it. How big a tool diameter can you use with this machine? Depends. Shank wise, you can, on an ER16 you can get up to 8mm. You probably shouldn't go above 8mm. But people do use things like Boss Tornadoes and insert mills where the shank is 6 to 8mm, but the actual head is, the actual cutting part of it is, oh, I've seen them go up to 40mm. I think, who was it that did the servo and the Masso controller on Milo? He had a mill that was like 40mm wide. Picture a Rep Festival, but catered to businesses. Oh, okay, yeah, cool. What do you mean? All Rep festivals are catered to business. It's the business of fucking about and making cool shit. So, generally, if I'm working with stock that I know is to thickness, I won't bother to do the first facing cut because obviously it's flat enough. But I also won't bother to do an adaptive cut. Reason being that adaptive will just take a bit of time to do. They take a lot of time to do. Adaptive is probably the most time-consuming operation that you can do, and it should always be considered a roughing operation. It should never be considered a finishing operation. But we can do faster of both of those operations. We can do faster finishing and roughing ops if we choose specific operations to do. So first thing I'm going to do is I'm going to make sure all the holes are aligned. So we're just going to do a bunch of bore operations. Yeah, we're going to basically do a bunch of bore operations. Before we do that, we need to set up some stock. So when I bought this, I bought it to be 5mm oversized on either side. I'm not too worried about that, so I am just going to pretend it is to size, or about 1mm oversized on either side, and it should just be able to eat through the rest of it quite cleanly. Because the operations I'm going to do anyway, I would normally do as 100% engagement for the contour anyway, so it doesn't really matter. A few of us also have the BAT 300R 10C cutter too. Yeah. It depends on the machine as well. Like, some Milos would be able to do it. I know one guy has a Milo with a 500 watt spindle on it. That's just voltage controlled. That will not do even maybe a 6mm end mill well. But some people have master. Someone's got a servo controlled spindle out there. Which makes no sense because the Z-axis stiffness is going to be the bottleneck before the spindle becomes the bottleneck. But anyway, I'm getting distracted. So,
Workshop VOC levels are suboptimal. Turning filters on.
Thank you. Keep me alive. So yeah, I'm just going to pretend the stock is 1mm wider in every direction except the top offset. I'm going to make sure that the top offset is 0 because I don't want to mill below the top offset. So that's going to be set to 0. And then the bottom offset is going to be the difference between the thickness of this and the thickness of the final part. I think the final part is going to be 9.4, so it's going to be 0.6 bottom offset. I'll just double check that now. Eye infusion if you want to measure something. So, no, I got that wrong. See, this is why we check things. It's 9.6, so it's going to be 0.4 bottom offset. I'm also like 3 meters away from my monitor, so you'll see me going like this all the time just to try and read it. You should have a stream dedicated to ranting and one dedicated to milling. But why not both? Why not both? With how today's gone, I might as well have a stream dedicated to drinking. Because I need it. Just mill it. I meant to say I should just cook a steak on stream one day. But I ended up saying I should just mill a steak. Should I mill a steak? Okay, cool. So I've got the 1mm offset because reasons. I've got the bottom offset perfect, so I now need to make sure that the orientation is set correctly and where my reference surface is going to be is set correctly. Ground beef. No, you wouldn't mill ground beef. You put it on a surface grinder. Come on, man. Jormungand, get with it. So box point. So if you've never done this before, basically you need to choose where the origin is going to be on the part that you want to make. Use a slot cutter. Is that to make the ridges in the steak so it grills better? Speaking of which, someone did mill flat the inside of a skillet on a Milo. It was crazy. So yeah, I'm going to choose the top left corner because that's normally the one I normally choose. If you've got the right machine profile selected, so I need to make sure that I select the right one. You don't need to change this orientation, but you should really check this orientation to make sure that the x-axis and y-axis are going in the right way. Right. There we go. And then we can choose some operations. So the operation is going to be really, really simple. There's a bunch of bores and counter bores, so we're going to use some bore operations. Then we're not going to do any drilling because drilling takes longer and has more tool changes, and it doesn't really matter in this specific scenario because we're not doing anything deep and we're not doing anything that needs the level of accuracy that a drill and ream cycle would bring. And then we're going to do a couple of contour passes. We're going to do a contour to shave down the actual contour, and then we're going to do a contour pass with a 90-degree end mill, and that's just going to give us our chamfers. If you don't know how that's done, I'll show you in a minute. There are some oddities with it though. Awesome. So now I'm just going to make sure that I have all the tooling updated. So where's my tooling at? There we go. It's my tool library. I should have a bunch of DMS ones loaded already. Do I have any of the 3 flutes loaded? I don't have any of the 3 flutes loaded yet. So I'm just going to walk you through how I would normally do this. Put it on.
Workshop air quality return to normal levels.
Thank you.
Turning filters off.
That's not going to get annoying throughout the night. I'm going to turn that off. Just lower the volume on it. There you go. So you guys should be able to see Fusion now. This is weird. Can you guys see the... No, you can't, can you? You can't see the tool selection window. Strange. Okay, let's see if I can show this to you. Properties. Fusion? There we go. Alright, so it shows up in a different window. There we go. Let me just make 2 of those so I can Windows capture, window capture. Okay. Alright. At least this way I can toggle between them. So when you go into tool selection, it's going to come up with a window just like this. I am going to do this. I'm just going to give it a name so that I can identify it. This one's going to be... What I'm going to pull out the end mills that I actually need. I've got the chamfer mill loaded up already, so I don't need to do that one. I'm going to need a 3 mil that is deep enough. Do I have a 3 flute that doesn't have a stupidly wide shank? No. Oh no. Okay, change of plan. Change of plan. So the only collets I have are 8 mil The only collets I have are 8mm, 6mm, 3mm. And technically the range goes, I have the ability to do down to 2mm and down to 5mm. But the 3 flutes that I have a shank of 4mm. I don't have any collets that can go down to that. The other option is what I have been doing and using single flute end mills instead. So unprepared on the collets. Yes, collets are expensive, man. I'm a computer scientist pretending to be a bad machinist with no clue about what he's doing. Let me make my mistakes. I guess it's picking up the window, not the screen. Yeah, exactly. Exactly. So that's what that was doing. Yeah. So we're gonna have to do. Oh, that's super annoying. That's super annoying. How long are you? Ah, god damn it. So this is the issue I had when I was doing the other stuff. The only end mill that I have that's that's long enough, sorry, the flute length is long enough to get all the way through 10mm plate is a 30mm long cutter. The next size that works that I have is only 8mm, so it won't be able to cut all the way through. The issue with this is you get so much deflection. You get so much deflection. So we're gonna have to do some kajiggering. Some kajiggering and kajoggering. Right, I'm still gonna use the 8mm as my facing bit afterwards. Yeah, still use the 3 flute as the facing one afterwards. Okay. So, where did I leave the... I am just going to pop this into the system with some guesstimations of feeds and speeds. What am I looking for? What am I looking for? Fusion. There we go. So, it is DMS dash 60 dash 8 X 8D 20 X 60. Perfect. Sweet. So that is my 8mm tool. I'm going to just add the parameters into it. So it is 8mm in diameter. Now, normally the overall length, the length below holder and stuff like that, it only really matters when you've got fixed holders. So if you're thinking like the press fit holders or the shrink fit holders, stuff like that, it doesn't really matter too much here. So what we're just going to worry about is we're going to worry about the overall length, which is 60. And then we're going to worry about the flute length as well, which is 20. Is that 20? Doesn't look like 20, but it is 20. Now, for shoulder length, we're just going to do the exact same thing because there is no shoulder on these tools. And then length below holder is also going to be 20. Cool. So this is the actual, what you're actually going to see in the tooling. The reason I do it like this is because it's a better representation of choking up on the tool. If you don't know what choking up on the tool means, it just means making sure the tool goes as far up into the holder as it possibly can before it hits the flutes. And it is a 3 flute carbide shaft. You don't need to worry about this. And then cutting data. So I'm gonna go at 24K, so 24,000. And ramp spindle speed is also going to be the same, so that's updated there. And I'm looking for a feed per tooth over here of about 0.025-ish. So I'm just going to go up incrementally in feed rate until I get there. So that's, there we go. $1,800. So that's perfect. So that's 0.025 millimeters per tooth. So that's pretty good. And the lead-in feed rate is also going to be the exact same. The ramp feed rate, I want to up that to around 500. And then the ramp angle is effectively how, if it's doing kind of ramp in, so those circular movements before it actually touches material, if you're doing a bore operation or anything like that, I'm gonna up that to 3 degrees, just because I know that Milo can take it. The higher that ramp angle is, the faster your tool will engage within the material itself. We got 17 people here. If you haven't done so already, make sure you drop a like down in on YouTube. It does help out the videos immensely, and it makes me smile. And you want to make me smile, don't you? Don't you just? So we can head over to main now. Oh, no. Abort. We're going to make sure that we turn this window back off, and we're going to keep that window back on. There we go. Juggling windows at the moment. Juggling windows at the moment. Awesome. So yeah, that is all set up now. We've got the tools that we're going to use for facing. We've got the tools that we're going to use for the contour pass, and we've got the tools that we're going to use for the boring operations. And also for the chamfering. So in total, we've got 3 tools, but we might need to do more than 3 tool changes, and that will make sense later on when we're actually doing the process of things. God, I'm really gassy today. So let's find some bores, shall we? Right, so in 2D, there's bore operations. Now, I like to separate my bore operations up in 2. I do counter bores first, and then I do normal bores afterwards. And the reason I do that is because sometimes when you're doing bores, Fusion can be a little bit of a pain with it, and do the full bore, the counter bore only somewhat, and then do the full bore afterwards. So this is more just a control of orders of operation thing than anything else. So I'm going to select my tool. I'm going to try and use, I don't want that one, I want single flutes. I want that one there. All right, so I selected my tool. What's the feed rate on this? 800 millimeters a minute seems about right for a single flute tool. Make some chips. I'm trying to. I gotta program the part first. I gotta program the part. Give me some time. So demanding, Marco. Also, welcome to the stream, dude. Welcome to the stream. Yeah. Then we're just going to select geometry. So I'm going to select all the bores. Now, you've got to be a little bit careful here. I'm just doing all the counter bores first. You've got to be a little bit careful here, because if you have a chamfer on the outside of, say, this hole over here, if you had a chamfer here and you selected the contour, what it would do is it doesn't account, when you automatically set it up, it doesn't account for the little bit of space that the bore is set into the workpiece because of that chamfer. So it only goes up to the bottom of that chamfer. So to fix that, you need to make sure that when you go to heights, that your top height is set not to the whole top, but to the stock top. So in this case, it doesn't really matter. Otherwise, you end up just crashing into that first like millimeter or half a millimeter of material. Marco, I can't move any faster. I'm trying to explain that shit here. I'm trying to be nice to people. I know I can do a 3 degree ramp in here. Right, so heights is good. I just need to keep selecting geometry. Awesome, so all the counterballs are selected, all the heights have been done correctly. Hey! Sion's here. How you doing, Sion? Ooh, yay, milling time. Well, let's get through the programming stage first. We gotta do that programming before we can do anything else. God damn it. God damn it. Don't worry. I have to learn at least... Wait. Don't worry. Something. You kind of offer. Don't worry, I learn at least much looking at you not making chips as looking at the machine making chips. Fair enough. Fair enough. Right, so all the balls have been selected. What I like to do is, because the bottom thickness is, there's that bottom thickness there, it's going to go all the way down to just the whole bottom. So I'm going to make sure that I've set it up so it actually goes 0.4 millimeters below whole bottom. 0.4, and that way it breaks through the whole of the stock. Don't do that unless you have a sacrificial layer underneath. If you don't have that sacrificial layer, don't do that, because otherwise you'll just mess up your fixture plate. Yeah, I don't like doing the job setup programming to newbies still. I enjoy it. I enjoy it. It's just weird doing it in front of people. Ignore what I just said. Ignore what I just said about going to below whole bottom. Because we're doing counter bores, if we go to below if we go below whole bottom, it means we're lowering the counter bore down. So ignore what I just said. For the counter bores, go to whole bottom. For the full pass-through holes, then you can go below. That was nearly really bad. Passes. I'm going to do multiple passes. I'm going to do 3 passes just because it's a lot of stick out on a very thin tool. And I'm going to do some conventional cutting. Step over. That's fine. Yeah, never do job setup on stream. It's like I should never code on stream, but I always do. Yeah. I get that. Cool. What am I getting a warning for? Some passes were discarded. Oh, okay. So I've got a warning here that some passes were discarded. Basically, because I want to do 3 passes, it can't get a tight enough angle, a tight enough ramping angle to do 3 passes. So it's just going to do 2 instead. It's nothing major. So let's see if we can clear that error at least by moving passes down to 2 step overs. There we go. Yeah. So that's error warning has now gone. And now we're just going to do a second boring op. So we've done the boring op for the counter bores. And this boring op is going to be for all the through holes. Now, you can, if you ever have a part that has counter bores on both sides of the part, I would recommend doing all the bores that go through, at the same time. So even if the counter bore that joins that hole is on the other side, still do it at the same, all the way through on one side. Now this is the point where that stock bottom matters, because you want to go all the way through the stock. So on this one, I'm going to make sure I go slightly below the stock. Hey Damascus Everglade. I'm just going to call you DE from now on, because saying Damascus Everglade is way too long. Hey DE. And it's going to be the same steps, so multiple passes, 2 step overs. I'm going to do 1 mil step overs with this one, just because I think it'll work better. Tools, same tool. No ID. Cool. Oh, I forgot to select the counter bores that are inside. So don't forget the counter bores that are inside. Sorry, the bores that are inside the counter bores. Otherwise, they're not counter bores. Ah, what have I done? There we go. Nice. Okay, so all the Fusion Cam. Yes! It's the most interesting thing in the world. No, it's not. It's boring. I just need something to do, really. Right. Some passes were discarded. Blah, blah, blah. Reduce tool size or decrease step. Okay. So in this case, I'll bring you guys in a little bit closer. So I'm getting a warning that the amount of step overs that I'm trying to get is too high for the amount of space that I have, so it's deleting some of the step overs and just not using them. That's fine normally, but I do want to make sure that these bores are at least somewhat precise. So what I'm going to do is instead, I'm going to take away multiple passes. There we go. I'm going to put stock to leave at let's put 0.3, say. So this, ooh, failed to generate toolpath. Why did you fail to generate toolpath? Huh? Why did you fail to generate toolpath? What is going on? What is going on? If I put stock to leave off, it generates it if I have stock to leave off. This is weird. Tolerances. Use ramp angle. Yes, yes. I'm gonna make sure that's 3 degrees. It can handle it. It's going to be a conventional cut. Got to leave 0.2. There we go. Fusion showing me its love, yeah. So the reason I'm doing this is I'm actually going to duplicate the whole thing. So because I can't do multiple step overs, I'm going to have a stock to leave, and then I'm going to duplicate the operation again, and then on the next operation I'm not going to have a stock to leave. And that basically performs the same thing as having multiple passes. It's just that Fusion didn't want me to have multiple passes, so this is the workaround for that. So I've duplicated it, I'm going to edit it. And I'm just going to turn off stock to leave. There we go. Hey Hans, how you doing? Oh my, you're using white mode. My eyes are burning. Does Fusion have a dark mode? Does Fusion have a dark mode? Wow. I need to look at this now. Grid and snaps? No. Display settings. Ground plane, offset, camera, object visibility, effects, environment? Grey room, infinity pool. No! How have I not learnt this until now? This is so much better. This is so much better. Hell yeah. I can't help it, no dark mode, but you can change the environment. Oh, it's a preview thing. I think I'm just going to keep it like this for now. Otherwise, we're just going to get sidetracked. Cool. So, I have the original bore operation, which is doing all the counter bores. The reason we're doing it like that is so that when we do the full-size bores and we're going from the top of the hole, you're not crashing into where that counter bore should have been removed already. The second bore operation has stock to leave because we can't do Fusion won't let us do any multiple passes. And then the third bore operation is just cleaning up the stock to leave from the last operation. They do all the exact same things, but yeah. Awesome, awesome, awesome. Right, next operation is going to be a contour op. Now, I know that this contour op is going to be a full engagement operation. So I'm going to set myself up accordingly to make sure I have the fan installed or some kind of air installed on my Milo. I use fans because I don't like using coolant when I've got the dog around. So I've just got the fan. He gets scared from the air compressor as well, so I don't turn the air compressor on ever unless I need to. So I've got the collet fan. That's going to make sure that it clears a lot of the debris and shit that will build up inside the slot as it's being done. I'm going to do this in two operations. So much like we did the contour op, much like we did the two bore ops where I did the same op twice, one with stock to leave and one without. I'm going to do the same thing with the contour op. Again, reason being just because we're using a really thin tool with a lot of stick out. It has proper dark mode now. Woo! Lol, that is way better. I need to change that. Fair enough. Yeah, this is so much better. The amount of times I've just flash blinded myself. By the way, I'm going to machine 75 alley tomorrow. How much harder is it to machine compared to 6061? Should I use similar setting? It's easier in some ways. So 5000 series and downwards, including cast plate. So this is one of the downsides of using cast plate. Is quite soft and gummy. On a machine with sufficient rigidity, like Milo, compared to a router, 7075 should be a cakewalk, and it should be nicer because it won't leave as many burrs, because it's a harder material. Harder materials tend to leave less of a burr, but then you can also get, if you think about steel, which is definitely harder than aluminium, steel leaves more of a burr because it's more elastic before break than aluminium is. So steel will leave more of a burr despite the fact that it's a harder material, but harder materials within the same category tend to leave less burrs overall. So you should have less cleanup with 7075, and it should be similar settings to the 6061, to be honest. You might even be able to feed faster. It's 7075 is only really a problem when you're facing rigidity issues, and you shouldn't be facing rigidity issues on Milo to that degree. Right, so next one's just going to be a contour pass, 2D contour. Now, here's a bit of a weird thing with 2D contours, right? If you notice, if I select this 2D contour here, what contour is it following? It's following the bottom contour with all the pockets underneath. So what I'm going to do is I'm going to go into the design workspace real quick, and I'm going to create my own custom contour for the bottom. All right. So when I selected the face, when I projected the face, so if you press P when you're in Fusion, you can project a face and it basically makes a sketch of what's already there. I'm going to make sure I get all the chamfers, because there are chamfers underneath. So the chamfers won't have registered because you're only doing it, it's on a separate face to the bottom face. So I'm just going to go around continuously pressing P, just so I know that the whole thing is set up. There we go. I'm just going to finish that sketch. So now I have a custom contour that I want to work with. So I'm going to go back into the manufacturer workspace. I'm going to go back into 2D contour, and then I'm going to select that contour that I just made. I'm just going to double check to make sure it's completed on all sides. So that's the custom contour I've done. Complete on all sides, awesome. So, because I've got the air blast, well, air blast as in the fan, I don't need to worry too much about going too slowly, so I'm going to pick an appropriate feed rate. I'm going to use the same feed rate for contouring as I did for my bores, which is 800 millimeters a minute, which should get me about 0.03 feed per millimeters per tooth, which is more than what I would call the bottom limit, and the bottom limit being 0.025. I always mess up with my chamfers, that's why I stop modeling them and just add them when I do setup. I've got to process what you mean by that. Give me a minute to process that. I use the CNC fan. Yeah, I like it. The only issue is you've got to worry about where you set up your stock, because if it's set up near another object, say your tool setter, for example, you're gonna fuck with something, and you're gonna smash into your tool setter, and you're gonna break either your fan or your tool setter. Yeah, I have a macro that's set up to clean the workbench after milling. Alright, I'm gonna do this in multiple passes. Now, this is where you need to be a little bit kind of hesitant with things. I won't say hesitant. So we're going to do multiple depths. I am going to finishing step down 0.1, finishing maximum roughing step down. So the maximum roughing step down on this is set to 22.5. That's just an automatic Fusion thing. Don't trust Fusion in this case. Don't trust Fusion. I'm just going to do 1 millimeter step downs because it's, again, a very thin tool. Now, I could do this contour with the bigger tool, right? But that just adds another tool change that I have to do. So I'm going to put it up to you guys. Would you guys rather I do it with the big 8mm tool, or would you guys rather I just do less tool changes, get on with it, and just use the 1mm tool? Sorry, the 3mm tool. So we don't see the pop-up. Let's Fusion 260 in your stream. Oh, you don't see the Fusion. Oh, never mind. Well, that's annoying. That's really annoying. Right, let me see if I can do Windows capture. Video capture device. Display capture. Okay, there we go. So got display capture up. 8mm sounds, so we don't see the pop-up. Yeah, the pop-up's now there, so I'm doing display capture instead of Windows capture now. So I just need to make sure I don't minimize anything, just in case. So you guys can actually see the settings now. So what I've done is I've just done multiple passes, maximum roughing step down of 1mm, because again, thin tool. 8mm sounds fun. Okay, cool. We'll do the 8mm. In that case, what I'll do is I'll change the tool. US3 flute. That's the only one I've added so far. So this is the 8mm tool. And I need to make sure that flood coolant is disabled because it's on by default. And I just need to check my top and bottom depth. Right, so it goes to stock top and then it goes to selected contour bottom. So I want to just get rid of all that material, and I've got a sacrificial base underneath it, so I don't need to worry about going too far down. So I'm going to go minus 0.4, and that should eliminate 0.8 to stock. What do you mean 0.8 to stock, Marco? So if I decided to do stock bottom, it would accomplish the same thing. So if I just change this from that, I'll change it to, I can just change it to stock bottom, and it will definitely, then I don't need to change anything. So yeah, that's one way to do it. There we go. I was doing 1mm depths. Awesome. Sweet. So what I'm going to do now, first things first, I'm going to just bring this above grid line because it's annoying me. I don't like looking through the grid. There we go. It's above grid line now. Might need to redo some stuff. Regenerate. Nope, that's fine. Almost faster to write the code by hand than starting at Fusion. Not a chance. Not a chance. There's nothing. If this was me by myself, I'd be done by now and be bringing it to the machine. But I'm trying to teach you guys. I'm trying to tell you guys how this works for the people who haven't done it before. I'm trying to talk through my process. I know that sounds really pretentious, but hey, sometimes you gotta sound pretentious. Awesome, that looks a lot better now. So I'm just gonna simulate this to make sure that everything's good so far. Yeah. Cool, so that looks good. One thing I forgot to do is we're doing the same technique with the spring pass as before. So I'm going to do a stock to leave. Stock to leave 0.5. So that's going to leave 0.5 extra stock. I'm going to duplicate this, and then I'm going to do it again, the whole thing again, but without the multiple passes. There we go. So I'm going to remove the multiple passes, so it's going to do everything in one single depth. I'm going to remove the stock to leave, and I'm also going to slow down the tool dramatically. And this just leaves a much nicer surface finish. So, where is my feed rate? I can barely see from this far. It's set at 1,800. I'm going to just bring that down to 1,000. Now, you would only want to do this on finishing passes. Yeah, 3D printed slices are. I like it more. I liked it back in the day where you actually had to wrestle with the slicer. It just felt like you were doing something. Just gonna get rid of this model. Right, let's do this again. Marco, I have no idea what you're talking about right now. You're just spewing words and settings, because you're not getting 800 RPM on a Chinese spindle. You're not getting that far down. Awesome, so that's the first contour. That's the one that has stock to leave on. And then that's the second contour. That does a full depth of cut. Yeah, perfect. So we have one more operation that we need to program, and this is the chamfer op. Chamfer op is a really simple one. There's multiple ways to do it. I'm just going to do it with a 2D contour. And I'm just going to select the bottom. I'm going to select the bottom contour here. Now you got to be really careful with this one because you're not offsetting it. So if you've got a blunt tipped end mill, if you're not using a pointed tip end mill that has the flutes going all the way to the point, you'll just leave a flat spot on the chamfer. But luckily I do, so I don't need to worry about it. So all I need to do is do it in a single pass. I'm just going to slow it down immensely to like 600 millimeters a minute. There you go. 1500 to 1000 RPM. Yeah, you're not getting that on a Chinese spindle. You are not getting down to that feed rate. Sorry, that RPM. The most you'll get down to is... Why is this not? Is it because I changed I moved the model? Edit. Body. What on earth? Why are you not processing correctly? Jake, can you show tool in setup so I can see which one you've chosen? Yeah, sure. Do you want the tool library or... So I've used this one. So carbide single flute, 30 mil. Marco, you're making no sense, man. And you're kind of just spamming chat at this point. Yeah, the 8mm is selected in the last contour. Oh, yeah, that's it. You're right. You're right. You're right. I forgot to select the chamfer. Chamfer, select. Okay. Current machine does not support. Oh yes, because I forgot to turn flood coolant off. Disabled. Yeah. Wait. Spindle speed is smaller than supported on this machine. 24K. There we go. I forgot to set up this tool properly. 600. Okay. Right. Let's do the whole simulation. What has happened? There's fuckery afoot. There is fuckery afoot. What has happened? I'm so confused. Why is it simulating it on the bottom? What the fuck? I'm really showing off my fusion skills here. Stock. That's set up correctly. Is it because I moved the model? I think it's because I moved the model before. Let's move it back down to where it was. Yeah, that's not right plane. I've never had this happen to me before. It just has to happen when I'm trying to teach people stuff, doesn't it? What the fuck? Edit. Start box point. Okay. Model. Okay. Alright, regenerate this all. Generate. I must have made insufficient offerings to the demo god. Of course, of course. Edit. Why? Why? Alright, I'm just gonna delete that and go straight 3D contour. $24K, blah, 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 blah. That's all done. Nice. Alright. Why am I getting an error message? The vertical lead out radius found in the linking tab is larger. Who needs to run a fan? The vertical lead out radius found in the linking tab. Okay, so it's something to do with linking. Right. I didn't mess with linking though. I haven't messed with linking at all. What? Selected contours, stock top. What the fuck is going on here? Right, if I simulate this all. Okay, yeah, so this is fine now. But when I try and (2D contour). Okay, why is it doing a 2D contour up there? Chamfer Mills. Okay. Fudge is disabled. 24,800. No, still doing it up at the top. I've reselected the contour like 5 times. There you go. So if I delete this contour and select it again, it does it all the way up here. What the fuck? Reserve feed rate. Warning, after raising the feed height, it is now above the retract height. I have not raised the feed height. retract height, offset 10 mil, stock top. What the fuck? Top height, stock top. Bottom height, selected contour. Those two are correct. Top height. This is really strange. Yeah, let's save it. Assemblies. Save. Let's try again. Let's try from the start. It's getting quite late around my parts, and I'm having a long day tomorrow, so I'll leave with good night and good luck. No worries, dude. Cheers for coming. Appreciate it. The big beginner fusion learning is that it does stuff like this to other people. Yeah. Yeah, it does. I didn't know tool changers were part of the paid version of Fusion until the other day. Yes, just generate it all again. Why? Whoa. That's just made it worse. The operation has missing references. Do you want to clear those selections? Yes. Model. Perfect. Box point. Selected correctly. Done. Generate. Right. Okay, it looks good now. I'm going to simulate it to make sure it's good. Fighting for CPU resources right now. Jesus. Normally, this would take like 5-10 minutes to program. It's been an hour and 12 minutes. Oh my god. Alright, so the next one is the tool change. Perfect. For the 8mm. Awesome, awesome, awesome. That looks good. Then there's the second contour pass with the 8mm. And then the chamfer. Awesome. Right, this looks promising. End simulation. Nice. Gonna save that just so that nothing else happens. Awesome work. Perfect, perfect, perfect. What I'm gonna do now is I'm gonna post-process everything. Post-process. What should we name it? What should we name it? Should we name it the Prey? Let's just name it Prey. I had to check with myself to see if it's Prey with an E or with an A. It's Prey. It's with an A, isn't it? Yeah. By the way, on Milo, what's realistic? What's realistically the biggest DOC I could do with a 6mm? Because I was thinking about trying to do something like a 10mm DOC. I think 1D is what you're normally looking for. Yeah, this is just the first side. This is just the first side. 1D or 1 diameter of tool is realistic, but at 50% step over. Or half D at full. Depending on how well you built the machine and if you have HOIs and installed, you could do a half D at full at full engagement, but I wouldn't trust that to do finishing passes or anything with. Or, yeah. When it comes to contours, I just play it safe because they're a fast operation anyway. Right, so you've named it Prey, you've done formats. I need to make formats are good. Probing and inspection at start, nice. Then we're gonna do everything else done. Right. Done. Awesome. So that should be good. That's going to post to a folder on my desktop. Different tools have the same tool number assigned to them. Post-processor will not perform a tool change, which may mean that the wrong tool... Why do they have the wrong tool number on them? This makes no sense. What's up with my tool library? My tool library. We're getting all the things happening on this stream, aren't we? Everything's happening. Oh, I know what it is. It's because I have them in different folders. They're different tool numbers. Renumber tool. Start from... How many tools do I have in my single flutes? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to start from 10. Renumber tool, start from 10. Increment by 1. Remember. So that's tool 10 now. So that will come up as tool 10 when I do my post-process. How to fix all the errors. So yeah, because of the ball screws on this, I've only been using single flutes on them, so I haven't had any of these issues. And like I said at the very, very beginning of the stream, this was going to be a bit of a fuck around because it's very last minute. Post-process. Hooray! Everything else is already set up. Why? Why? Oh, fuck. It's because the chamfer mill also has the... Hold on. I gotta get my tool library in order. Right. How many 3 flutes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11 3 flutes. So if we just... Ugh. So 10 plus 11, 21. So if we start this one at 22, renumber tool, start at 22. Right. So 10 is there. I've got a load more. I've got 12 more tools that will then fill this slot up. Okay. Let's try this again. Just going to generate it again just in case. Just to make sure. I've never really had these issues before. I've never kept folders for tools before. That's because I've never really had that many tools that were different. Oh, for fuck's sakes, why? 2D contour. 2. What the fuck? Can you explain why you're having to set tool numbers? I've never had to do that. I can't explain it, but it shouldn't bother. You shouldn't, because I'm using multiple different tool libraries. So I've got a subfolder for 3 flutes, for chamfer and mills, and for single flutes. Now, up until this point, I've just been using single flutes. Now, the issue is whenever you create a new subfolder, the tool the tool number changes. Sorry, the tool number resets unless you say specifically, I want this tool to be a different number. Hold on, cutting. Number. Accept. That's now T3. Shouldn't be T3, it should be T edit. The reason you set tool numbers is to know where it is set up in the machine. So if you have tool cartridges or anything like that, if you have tool cartridges where it needs to figure out which tool it's pulling from where, because it doesn't, machines don't know what tools they're using. They just know in terms of like, they don't know the difference between a 3 flute for a 1 flute, blah, 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 blah. They only know that it's tool from position 1 or tool from position 3 or this, that, and the next thing. So it just knows the tool number, just assigns it a random, not a random number, but a number. Is my guess. Processor. There you go. So if we make that tool 10, accept, close. Why is it still coming up as tool 3 though? Yep, gotcha. Why is it Fusion? You are doing my head in this evening. Right, let's try this again. Close that down. Restart it. Oh, I can see people getting bored now. Oh, they came to see machining. They're not getting machining. Generate. Why is that still coming up as tool 3? This is really bothering me. Right, I've changed them all to a different tool number, but I'm going to have to figure that out at some stage. Right, hopefully this works. Post-process. Hey, we did it. We did it with no errors. Perfect. No. I don't want you to see that. Well, you see my beautiful face. My beautiful face. Cool. Stream might freak out a little bit because I need to connect to Milo. So let me know if I'm still on your... if my beautiful face is still there. If my beautiful face is still here. If my face is still beautiful. Still there, but not beautiful. Definitely not beautiful. On top of my chest it is. What? What does that even mean? Anyways. So what I'm going to do is I'm just going to upload that over to going to connect to Milo. I'm just going to upload it straight to there. And then we can do some probing stuff and do the cool shit. Finally get the cool shit going. System jobs. I need to get rid of all these old jobs so I don't get confused by them. Delete. And then upload G-code files. Pray. Sweet. Thought you were wondering where I left my head. Oh. Time to move over to a glass of red instead of cola. I wish. I wish. It's been one of those days. Sion, it has been one of those days. But we get to do the fun thing now. We get to go inside the machine. This is going to be put you over here. Can you guys see up there all right? Can you see the inside of the machine all right? Or do you want me to make it bigger? Whilst you guys answer that, I will get all the probes and stuff out. Probe! We also need to do some setup as well. Yes, we can see it, but bigger is always better. Cool. How's that? Sweet. So we're going to be using the tape method today. If you don't know what the tape method is, it is the sketchiest method that you can use, but it's also actually one of the safest. As long as your cutting parameters are set correctly, you're fine. So what I'm going to do is I'm going to lay out some masking tape on the back of the piece that I want cut. Make sure that they're not overlapping too much, because otherwise you create a slight slant in the part. And you want to avoid as much slant as possible. And I've got some thin tape here as well. Better it is. Cool. Sweet. And I'm just getting a scalpel so I can cut these bits off. The only way we do things around here is the sketchiest way we can possibly think of. What is sacrificial base today? It is a 3D printed part. I actually have an extra one over here. So here's one I made earlier. So effectively it is just a 3D printed, slightly smaller, because like this is what I can fit on my printer, version of the fixture plate. It's through holes instead of threaded holes, so you just go straight through and screw into the threads on the other side. You need to face this before you do anything, so the one in there is already faced off. And then you can use this as a sacrificial plate, so if you mill into it or anything like that, it's not going to be too much of an issue. This is printable on most printers. The only thing you need to worry about is it's quite a thick bottom layer. This is like a 7 or 8 mil, sorry, not mil, 7 or 8 layer thickness, so that you can get enough material to hog away and still have enough material underneath to support itself. So if you can print it, most enclosed machines can do it. I printed it on my P1S. If the P1S can do it, most Vorons can handle it. Maybe not the switch wire, because the switch wire is quite a big volume to heat up. No, not 100% infill. It's 20% infill. 4 walls, 3 or 4 top surfaces, because the top surface doesn't actually matter, but 8 bottom layers. And it's just ABS. Don't use PLA. Don't use PLA. I'm not sure if you can get away with PETG, but sounds like you probably can. But yeah, ABS is fine. Nylon should be fine. Yeah, lots of stuff should be fine. Lots of material should be fine. Just don't use PLA. PLA will melt and just be a globby mess. Awesome. So I've put masking tape on one side of this. I'm going to do the same thing on the inside of the chamber, just enough so to cover where I'm going to be gluing it down. Now, what I did earlier today when I was doing some other work, I made sure I wiped this sacrificial plate down. If you have any kind of solvent on it, if you have WD-40 that's left in the air, anything like that, that's going to make this tape peel up. And you really don't want it to peel up. So if you're doing tape method ever, make sure you're not using coolant. That's the one thing. We're actually going to use WD-40 later on as a release agent. Now, depending on who you are, you might want to cut off these ends. I am pedantic and I like cutting these bits off. Just make it look a lot nicer. But you don't actually have to. Now, you need to make sure you get these lined up perfectly as you can from the get-go. I wouldn't use this as a precision work holding method. This is more of a you're doing this from stock type of method. But the moment you press these two together, they're going to start curing. The super glue in between them is going to start curing, and you're not going to be able to twist them for very long, maybe 2 or 3 seconds. So I'm just going to use my fingers on this edge and press this up against here and then kind of lay it down in a tapered fashion just to get a semblance of being square. The probe and the actual machining will make it square no matter what. But getting it most of the way there is kind of best practice. Taping of the surface reminds me of starting days of 3D printing to keep the model adhered to the build plate. So 2011 ties. Yeah, the old blue painter's tape. God, I hate those. I don't miss those days. Right, so I have about 1 minute. So using my fingers, I'm just going to slide it on so it's roughly square. There we go. I'm just going to put some heavy weights on it. I'm just using some 1, 2, 3 blocks here. There you go, and press it down. Right, that's going to take about 2 or 3 minutes just to cure. And whilst it's curing, we can have a chat. How is everyone? 2 surfaces and super glue in between. Yeah, that's pretty much how it works. Believe it or not, that's a really strong bond once it cures. Like, I'll show you. I'll try and wrench on it in a minute. Generally, if I was doing this by myself, I'd take 10 minutes to just make sure that it's cured, but yeah. You can use activator as well. but activator's expensive for just canned water. If you don't know, if you didn't know this, the activator spray that you get to activate cyanoacrylate superglue is just water. That's what creates the bond in cyanoacrylate and Ca glue, is just water. Is just standard masking tape or anything special? Yeah, it's just standard masking tape. Just standard masking tape. Blue tape works as well. The same stuff you'd use on the old 3D printer beds. All right, let's check it. Right, so normally, like I said, normally I'd leave this for longer, but we don't really have that much time. I'm going to show you how strong this is. I'm just going to wail on this. Yeah, it's not going anywhere. It is a really, really strong bond once it's on. Right, I'm going to need a 6mm collet. I have a 6mm collet. Stick it in the machine. If you're ever working with collets, I'll do this on here. If you're ever working with collets, just make sure that you have clipped it in, because I've seen so many people make this mistake where they'll just throw it in there, put their tool in and expect it to work. You have to make sure that you're pushing it in until you hear it click. And there's a little groove that goes all the way around that needs to be engaged before you can do anything. If you don't hear that click, it's not ready. Marco, man, if you keep just spouting nonsense, you're just gonna get banned. This is your one warning, bud. If you just keep shouting, putting stupid shit in chat, you're just gonna get banned. Sweet. Do you screw the printed board or use the same masking tape? Yeah, so each corner of the printed part has M6 screws in it that go down into the fixture plate. So yes, it is screwed down. I don't really want to tape anything to my fixture plate. My fixture plate I want to keep alive for as much as possible, for as long as possible, despite the fact that I have a gouge in it just here. Awesome. So now it's probing time. Whee! So the probing is part of the post-processor on this one. So I'm just going to run... the job itself, and that should open up the probing screen. That's a maker mark. Yes, yes, a very perfectly round and about 2mm deep maker's mark. So I was going to do a homing cycle now. So is that the new shorter length of the V2 feature plate? That's much shorter than 1.5 plate. Yes, yes it is. So, oh, it failed to home. So yeah, the fixture plate on V1.5 took up the whole bed, despite the fact that there's 2 dead zones on either side. So that's just a lot of extra expense for spots that you can't use. So And if you wanted to do the full bed size, then we wouldn't also be able to do Miley with the same part. So the moving part on Miley is the actual fixture plate itself. So the bed stays the same and the fixture plate is what moves. If you had a longer fixture plate, you just end up, you throw away all the advantages you have from the smaller footprint of Miley. So all the features that you need to build Miley are built into the fixture plate. It also means that you know exactly where your machine's travels are at all times. The amount of times I've had stock on my V1.4 and got ready for something, for an operation, a set of operations, and then it was slightly too far to the left or right because I couldn't see where it was actually needing to be placed, would surprise you. I get what you mean, Jose, but at the same time, we haven't talked about voltages and we haven't talked about resistances and a lot of stuff that he's been spouting in chat. So I've given him fair warning. Yeah, I do the same. I've had to move things because it was out of reach. Really annoying. Yeah, it's super annoying when that happens. Okay, cool. Right, it's home correctly. Anyway, probe tool. Blah, 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 blah. Need to activate it by hand. Probe's been detected. So it's now going to go over, it's going to probe over the fixed point. So on V2, there is now a pin that gets reused. So the pin is next to the tool setter and you use that as your reference surface. So instead of having to just pick somewhere on the bed and use that as your reference surface, the reference surface is built into the tool setter. I forgot that I made these macros really slow back in the day, when I was struggling to get a top speed, a better top speed. So oh my god, this is taking forever. So that's probing the reference surface now. There we go, it's probed it. So from there on, the tool has a reference that it can work from. So whenever we're changing tools, it knows what the difference between those two surfaces are. Before executing cutting operations, it is necessary to identify blah, blah, blah. So that we're doing work coordinates now. Probing. That's excruciatingly slow. Even normal speed on Milo, V1.2 is too slow. Yeah. So I said it like that. I need to go through my macros. Basically, I had Stealth Chop enabled, and Stealth Chop for some reason was causing a whole load of speed loss, of torque loss. So if I ran 1,000 millimeters a minute, it would stall the machine. Since then, I've just got rid of Stealth Chop entirely since I identified that. And it's still got the issues of it being a 4mm lead versus an 8mm lead. Sorry, 2mm lead versus an 8mm lead. So still not as quick. But I changed those macros initially to work with the old speed, the old probing speed, so the old max speed. I can now change them. I should now change them. I just haven't got around to it yet. So we're going to pick Vice Corner. I don't know why it's called Vice Corner, but that gives you Z, X, and Y. And then I need to turn tutorial mode off at some stage. Okay. Pro Vice Corner, continue. We're going to do a full one, so I know that it is... How big is the stock, actually? I think it is roughly 125 by 170. So I'm just going to go back. So 100 should be enough. 100 should be enough on either side. You don't actually have to do the full length. How far away from the expected surface? Yes, 10 mil is fine. I want you to probe down 5 mil. And then what you need to do is you need to run the probe roughly over that top surface. So, see, that's the speed I can get to now. So that's 3,000 millimeters a minute versus what it was doing before, which was 600 millimeters a minute. Right, just getting that roughly over the corner. Cool. And just lowering it down a little bit more. There we go. Front left corner is what we're selecting. Please enter the depth of the probe in millimeters relative to the top surface of the work. This is 5. We will now probe the top surface. Blah blah blah. Cool. All right, so it's now going to move to probe in the Y direction. I haven't changed the speed of this, by the way. This is just the normal RepRap firmware, so the normal Millennium OS probing speeds. But this is kind of what you want because you don't want to bust your probe by going too quick. Is there a possibility to share the screen, the operation of the machine? I can do that. Make that bigger. That bigger. How's that? That way you have both. Cool. So that's probed the corner. It's now sitting directly over the corner. And it's going to ask me whether I want to do... I want to keep all that, so I'm going to press continue. I don't want to modify it. I don't want to reset it. So I'm just going to continue, continue, continue. And then it's going to ask me if I want to continue. Continue. There we go. It's going to ask me if I want to work, if I want to do rotation compensation. So rotation compensation is if you've probed it and it's not sitting perfectly square. It doesn't really matter when you're doing from raw stock, but I'm going to enable it anyway, just in case. Please ensure the touch probe is now stowed, so I can take the touch probe out. I can load up our first tool. So I'm going to need a 3mm collet. And a 3mm tool. Collet, 3mm tool, and we're just going to tighten this up. Make it nice and tight. And then we can press OK because the tool's been loaded. Tool changes required. Blah, blah, blah. Single flute, 3 mil. Perfect, that's done. And now that's just going to go probe the tool height, and then stuff will go spinning. I'm going to go mute when it starts going, and I'm going to just full screen the machine when the spindle starts, just because it's going to be loud. Actually, we can go over to the machine now. Right, I'll catch you guys in a bit. See, it doesn't need the fan for this operation. The operation is it's good enough to. The bores tend to extricate chips quite well, so you don't need it for this one. It's only for the contour, but we don't even need it for the contour because the tool is bigger than the extra stop now. We would have needed it if we were just using the 3 mil tool, but we don't need it anymore. I think I messed up some feeds and speeds, but it's working fine. It's actually pretty quiet. It's Blanchard ground, so this is cast aluminium plate. It's gummier than normal plate is, but it's Blanchard ground. So there's two basically drum sanders, disc sanders that press themselves against each other. So both sides are decently fat and decently parallel. It's good if you don't want to do surfacing. Yeah, I'll show you the difference. I'm just going to crack the door slightly, and you'll hear the difference in sound between having this and not having it. So, this is your normal sound. That's the sound it makes when it's open. Hopefully you guys can actually hear the difference there. You know the funny thing? I didn't have noise cancelling on there. It's just clipping so much that it's not picking it up. That's how loud it is. But yeah, it's a good 3 or 4 times louder. Now the noise cancelling is on. It's definitely got something to do with the feed rate. I don't know why, but the feed rate is really high, despite the fact that this is a single flute. Like, we messed something up in Fusion, but if you get the feed rate correct, and if you get your spindle speed correct, milling can be actually very quiet. It's all about the frequency of when each edge is being hitting the next piece. There's a YouTuber, one of the YouTubers who inspired Milo very early on. Forget what his name was, but he has a whole deep dive into it. Oh, and the tool isn't broken. The tool's still going. It's just quiet. That's all. It's not so quiet that I know the mill is running. I know the mill is here. It's not that quiet, but it's quiet enough that, yeah. So here's the thing. I've got noise cancelling on now, so you can only hear it when I speak. Noise cancelling's off. Yeah, noise cancelling's off now. I have no noise gates on. If I go through that door, I can't hear it. Hey, you're the one who came to watch a milling stream. Can't complain when holes are being made. That's kind of the whole point of the machine. This is the first time I've done any milling since I fixed the feed rate issue. And holy shit, travel moves are quick. Holy shit. I was used to travel moves at 800 millimeters a minute. These are going at 3,000. Imagine what it would be like on the TR8 lead screws. You theoretically could go 4 times faster on rapids. Question is, are you brave enough to go 4,000? Sorry, not 4,000. 4 times faster. Are you brave enough to go 1,200 millimeters a minute? Sorry, 12,000 millimeters a minute. Go, Brewer! Nice to have you, dude. Nice to have you. Sorry about the noise. The 1.5 should be able to go faster than these ball screws. The thing is the movement per rotation. So the lead, so which is the how far up the thread you're moving per full 360 rotation of the motor, is higher on the TR8 lead screws that Milo V1.5 has versus the ball screws on here. The ball screws, for every rotation here, for every full rotation, they move 2 millimeters. On Milo, on V1.5 and any Milo with a TR8 lead screw, they move 8 millimeters per full rotation of the motor. So if your RPM of the motor stays the same between A example and B example, then the speed is quadrupled with the lead screws versus the ball screws. It'll be released probably. I don't know. I think the CAD release should be in the next few months. We can do a CAD release. It's all the manuals and stuff. That's the issue. It's whether or not we want to, because no one's going to be making a V1.6 kit. In terms of what I mean by a V1.6 kit is a ground up V1.6 kit. There might be people who are doing upgrade kits. I don't know yet. So do we want to allocate resources into doing the manual to build the entire thing from scratch? Or do we just want to say, oh, this is what you need to upgrade it, and these are the things you need to do to upgrade it in this order? So we need to make that kind of decision. Most just want the wake cover, yeah. Everyone's been bugging me about the wake cover. I've been getting like 10 messages every week about what's happening with Atlas recently. Just stop asking me what's happening with Atlas. Nothing is happening with Atlas right now. Atlas is sat on the floor next to me. Well, the y-axis is. It's not going to be a project until later this year, at minimum. We need to worry about V2, V1.6, the electronics box, and the tool changer for now. Also, if we get the tool changer right this time round, we don't need to worry about it when Atlas releases. You can just use the same tool changer, and that's kind of a priority for me. But yeah, I'm really proud of those wake covers. You'll need to you can keep the Z-axis from V1.5. You can, yeah, it'll be a full rebuild of the X and Y axis to get the, because you need the new XY plate, so that requires the X-axis to be rebuilt to get the wake covers working. Or you can keep the Z-axis if you want. ATC, we're working on an ATC at the moment. If you have a look on the channel, there are some shorts of an ATC that Bright has cooked up. A really cheap one and a really good one. It's based kind of on the same principle as the rapid change. The rapid change works really well, so that's being worked on. We did the stream yesterday on my version of it, but I'm going to stop working on that version because it's just not good. But we're just going to focus on Bright's version, and that works perfectly. So yeah, that's an ATC is around the corner. It's not even that far off. But again, I'm not developing that. Bright is developing that, not me. Okay, but using mostly the same parts from 1.5 or acquiring a lot of new parts for the XY rebuild. So 3D printed parts are all different. Same rails, you can use the same screws, you can use the same screw nuts. You'll need some new fasteners, and you'll need a couple new bearings. For the most part, you're keeping around 60 to 70% of what's already there. Extrusions are all the same, rails are all the same, screws are all the same, screw nuts are all the same. You need some new bearings, but you also reuse some of the 608 bearings. Honestly, if you put your head down, it's about a day's work. Oh, you'll need the new plates, but the new plates can be milled on the 1.5. Atlas is not V2. Atlas is its own machine. Atlas is going to be... you see this? Hold on. Hold on. Where is it? Right. Do you see this space kind of right here? Right here. Between Milo and my workbench. That whole space is going to be taken up by Atlas. It's going to be a gantry style machine, but it's going to be fucking big. It's going to be roughly estimating at least 150 kilos of machine. It's going to be twice the work envelope of V2, sorry. So it's going to be 400 by 350. But it's going to be more geared towards, like, you have a small, you might, how do I put this? A lot of workshops have a top-bottom allowance, but they don't have a width allowance for machines. So going a gantry style machine that's just big and chunky means that we can get, we surpass the downsides of having a gantry machine, because gantry machines are notoriously bad for stiffness, but we just get away with it by making it extra chunky, effectively. And it's going to fit in this space here, and it's going to have twice the width, the working width. Did I once hear mention injection molding project? I'd love to. That is a way off. That's like 4 or 5 years down the line. I really want to do an injection molder. I think here's the thing with CNC. It's involved and people struggle with that, but I think CNC's opened up a lot of kind of the business side of the pro user or the enthusiast. And when you add an injection molder into that, it means you can use your 3D printers to rapidly prototype it, use your CNC to make the molds, and then when you're ready, you can have a desktop injection molder ready to go with all your scraps, or if you want to recycle, and you can push those parts out the door. So you don't need to buy that $1 million mold. How did you do the camera move? It's an OBSBot. It's an OBSBot Tiny 2. It has AI tracking on it as well, but I disabled it because it kept tracking the wrong times. And it has like hand gestures that you can do. I didn't like it. It was constantly shifting on me when I wasn't trying to get it to shift. I'm already saving my scrap ABS and SA. I used to do it. I used to have the box of shame. So whenever I do a project for the last like 3 Milos, whenever I've started it, every single part that's gone wrong or been defective or I've updated, I've put in a box and I've saved it. That's been my box of shame. And my box of shame, I empty out at the end of each development cycle to see how much waste I've produced. And then I throw it away, unfortunately. But for example, V2, during that whole development cycle, so Miley and Milo, V2, I used approximately 25 kilos of ABS. And when you think about that, at $20 a pop, yeah, it's expensive to do this. It's expensive. So, if you do want to, if you do like the stuff we're doing and you do want to contribute a little bit more, there are some links down in the bottom, down in the description, to a PayPal and a Patreon if you want to donate. Your donations go really far in making this project continue to be what it is. And right now, I'm going to be honest, we're struggling with funding a little bit. So if you want to see us continue doing the stuff we do, consider donating. You don't have to, but it does help out. Yeah, precious plastics is cool. I like the whole precious plastics project. Precious plastics project. Yeah. It's weird that you can talk specifically about the Pacific, but not specifically about the specific. Oh, cool. Right. That's tool 1 done. So it's gonna. Insert unspecified. What tool was next? It was the 8mm, wasn't it? I think it's saying unspecified because of all the tool number shenanigans that we had to do. I'm pretty sure it was the 8mm. Yeah, so it was the 3 boring operations, then the 2 contour. But yeah, that's ice cold. That's what happens when you use feed rates properly. All the heat goes into the chips, and you don't need to worry about it. It's great. It's great when you do stuff properly. I want to donate so badly, but the student job paycheck's terrible. Oh no, I get you, man. If you can't donate, don't worry about it. I'm not. The project's still going to continue. It just means that it's going to go very slow. And because I'm unemployed at the moment, that makes it even harder. Chunky boy. But any donations help. If you do want to donate, I always say it's better to donate $1 a month rather than $12 a year, $12 at once for the year, because it means that we can predict how much money we're going to be making every month, and that means that we can plan things out in advance. So I always say smaller, more often. If you can donate more often but smaller amounts, I'd rather you do that. But anything does help. Anything and everything does help. Chunky time. All right, I'm going to add the fan on this one. I'm not muted, am I? Okay, you can hear me. I got scared that I was muted there for a second. Why have you started slipping? There we go. If you ever do use these fans, I might release one soon for ER16, which is the collet size that we normally use. There's a little sign that says up. Don't install it backwards because you will destroy stuff. Make sure the up is facing up. All right, so it's going to do a tool probe now. So I've never milled at this feed rate before, so I'm going to have my hand over the e-stop just in case. Ah, shit. It happened. It happened. It happened. Basically, this is the downside to having the ball screws. This is the downside to having the ball screws. The ball screws don't spin fast enough. You can't spin them fast enough. It wasn't a crash necessarily. It's the fact that there's not enough torque in the ball screws at those high RPMs. So when you're doing 3-flute stuff, you need to be moving quite quickly. Yeah. So that was a lost step. That was a stall. Okay, time to leave work. Glad I could catch you. No worries, Cobra. Yeah. Okay. That's fine. Nobody panic. Nobody panic. Nobody panic. Nobody panic. Alright, there are methods. There are methods that we can take to save the part. So the work coordinate system has been saved, so I don't even need to reprobe it. But I do need to repost it so that we're not doing all the stuff that we've already done. I'm just going to make these a little smaller. So I'm going to just repost that contour. These two contours here as its own operation, because that's where it's stopped. Oh, it homes backwards on the y-axis. Yeah, no, it homes towards the column now. Yeah, so this is the thing. When you're using the lead screws, you can get to 3K quite comfortably. Absolutely fine. No worries. It's when you're using the ball screws. Because again, you need to spin the ball screws at a higher RPM. And when you go higher RPMs with the steppers, because the lead is smaller, you need to spin the steppers at a higher RPM, and when you go to really high RPMs on the steppers, what ends up happening is you lose too much torque. So the moment it has a cut that's too big for it, because that was a 1 mil deep, 8 mil wide cut at one point. The moment it did that, it had too much resistance. It skipped steps. Luckily, it didn't skip steps in a way that was destructive to the part, so we can actually recover this part. All we're going to do is we're going to lower the feed rate down for those two operations. Edit. And because we're lowering the feed rate, we need to make sure that the chip load stays roughly equal. So we're going to actually lower the RPM, believe it or not. I'm going to lower the RPM to 20K, and I'm going to lower the feed rate to 1500. What does that give me in terms of a... Oh, lucky guess. That's exactly the same feed per tooth now. So yeah. So the ball screws give you that extra precision, but you lose so much high-speed torque. if anyone had bothered to watch my video that I posted, the second video I ever posted, you would know why. And so I go into much more detail in that video. Cool. That's going at 1,000. Right, so I'm going to repost these two. Where's both places? There we go. I'm going to call it Prey 2. But I'm also going to change it. I don't want it to home, because it's already home. Tools, no. Configurations, no memory node, no. Single setup, no. Output tools, output version details, check Millennium OS version. Restore rapid movements. Done. Just need to reconnect back to Milo. By the way, wouldn't a higher pitch ball screw solve the torque issue? For example, so yeah, you can't fit anything bigger than 0802 in, again, watch the video, second video I ever put out. I explain all this. You can't fit them. 0802 is the highest pitch ball screw that we can fit inside the extrusions without modifying them. We don't want to modify them because that requires grinding down, and not everyone's comfortable with an angle grinder, and you might destroy a part, and it's going to be expensive, blah, 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 blah. So effectively, have to move... So you effectively have to move a 3-flute 50% faster, or is it tooth depth makes more? So you actually need to move it 3 times faster. So if the RPM stays the same, and you're going from single flute to 3-flute, you have to triple the feed rate. You can lower the RPM down, and that will help. It's all a balancing act. So for example, what we did earlier, so we got a feed rate of 0.025, which is a kind of the minimum, the lower end of the feed rate that you want to do, of the chip load that you want to do. And that was at 24,000 RPM with a 3-flute at 1,800 millimeters a minute. When we lowered the feed rate, we're also lowering the chip load, but we don't want to do that. We don't want that chip load to drop too far down. So in order to bring that chip load back up, we lower the RPM. So we lowered the RPM to 20K, and that means that the chip load, the thickness of the chips that you're creating, stays the same. Right. There's not an ideal chip load. Basically, you want as high a chip load as you can manage. There's no such thing as an ideal chip load. If you can achieve a chip load higher than 0.025 feed per tooth, do that. But that's based on your other parameters, this, that, and the next thing. You can always lower the depth of cut if that's an issue, if you want less force on the tool. So that was another option that we could have done. We could have lowered the depth of cut. I'm just going to lower the speed factor down to 80% for the first bit. There we go. So it stalled again. So it stalled again. So this is the thing with ball screws. This is what I've been talking about this whole time with ball screws. This is the whole issue with running ball screws, is you can't run those high flute count tools. Because the moment you try and run those high flute count tools, you run out of feed rate. This is why the screws, despite the fact that they're not ball screws, are sometimes better. Because if I had my lead screws in here, if I had the TR8 lead screws like we had on V1.5, and there is an option for it on V2 as well, there is an option for it, so don't despise. If this was a one flute tool and I was sending it at 1,000 millimeters a minute, be no issues. But it's not. There is the fact that it is quite a big tool, and we're doing quite a large step over with it. So if we went down to like a 5mm or a 6mm tool and we were only engaging it 50%, we could probably send it quite a lot higher. But we can't do that right now. So what I'm going to do is I'm going to do two things. I'm going to lower the depth of cut, but I'm going to keep all other parameters the same. And we'll see if that helps reduce the tool load. Because I can't reduce width of cut on this cut because it's a slotting cut. And slotting cuts are always 100% engagement. You can't really get bigger steppers than these. You can get different ball screw leads, but not at this size. So the ball screws are fine if you're just running single flute tools. If that's all you want to do, and we're going a bit beyond what the typical cut would be on this machine, because we are running at a 1mm depth of cut, but at a 100% radial engagement. And a 100% radial engagement is just a lot. 100% radial engagement on an 8mm tool for Milo is a lot of force. Again, we're going to reduce the depth of cut now to see if that helps with anything. So that should reduce the amount of force acting on that big 8mm. If this was a 6mm, we could probably send it right now. But we're not, because we wanted the big chunky boy. Because big chunky boy is big chunky boy, and everyone loves big chunky boy. Isn't that right, Brisket? You are the big chunky boy. If you've never come to a stream before and you're wondering why I'm just talking to this floor and calling it Brisket, my dog's called Brisket. Score point ordered. Blah, blah, blah. So I'm gonna go back into Fusion. By the way, bit off topic, I was thinking about just for fun how much extra stuff I can mod on my Milo. I was wondering if I'd cast epoxy granite stuff to like this. Yeah, it's gonna help. Any weight you can add to Milo is gonna help. Yeah. So we're pushing it right now. Again, we're pushing it because these are ball screws. We're not pushing it. If this was TR8 lead screws, there'd be no issues right now. There would be no issues. I need to edit. I need to edit the depth of cut on this contour path. Edit. So we're going to go for let's go for a 0.5mm engagement. 0.5 5. For the other one, it doesn't really matter because it's going really slow anyway, and it's only cutting a very small amount, so we don't actually need to edit that one. Post-process, tray 3. Luckily, IE stopped quick enough on both of those that I don't need to worry too much about it. Mr. Hans, I can't answer that. Any weight is good weight on Milo. Any weight is good weight on Milo. But that's to help with vibrations, not necessarily stiffness. I would need to see how you're planning to add epoxy granite. And I'm going to tell you this now. Everyone has the idea of filling extrusions up with epoxy granite and messing with epoxy granite. And I love it, and it's a good thing to do. But you don't know how messy it is to work with epoxy granite. It is messy. Oh, damn it. I forgot to post-process properly. Forgot to do expert mode. Oh, no, it did post with expert mode. Okay, that's fine. I just don't want to have to probe again. All expert mode does is it stops the it doesn't ask for probing before whilst the tool starts, when the program starts. So it's going to home now. Yeah. Mr. Hans, basically, I can't answer your question unless I know specifically how you're going to add epoxy granite. It might help, it might not. Is the center to center of the rail 60? No, it'll be... Yeah, it will be 60 mil. Yeah, you're right. Yeah, center to center is 60. But that doesn't matter too much. Because it's not it's not the major loading direction. So if you think about it, your y-axis is, your major loading direction is back and front. It's about the x-axis, right? And the center to center in the x-axis direction won't matter. The center to center in the y-axis direction will. The center to center in the y-axis is, I think, 80 mil. We fucked something up because I've not touched that top corner yet for some reason. I'm afraid we fucked it up somehow. It's all right, I've got some spare stock. If I fuck this part up, it's fine. There we go. So because the force on the tool has been reduced, we're not skipping steps anymore. So it's always about checks and balances and balancing how much stress you're putting on the tool versus your chip load, and the chip load is balancing feed rate, RPM, and flute count. So it's all these little things, balls that you have to keep up in the air at once. So by halving the depth of cut, we've effectively halved the amount of force that is impacting that tool. Now, from how it's cutting, I have a feeling, this is just a gut feeling, that we can increase the feed rate now to not fully make up for time lost, but we can definitely increase it a little bit. So I'm going to increase it to 120%. So this way we're just making up for a little bit of lost time. So that 120%, too much. My feeling didn't pan out. That's fine. So my feeling didn't pan out. That's fine. This happens. This is what happens when you're running new tools and new recipes. So I know that 120% is too much. So I'm going to back it off. I'm just going to keep it at 100 because I know 100 was good. I'm just going to redo that one. I'm not going to repost it or anything because I don't need to. So I'm just going to connect to that. I'm just going to load the same work coordinate system. Okay. I'm going to home the machine. And I'm just going to run it again. Again, if we were running a 6mm tool, I don't think we'd have as many issues as we are having. But we don't want 6mm tools, we want chunky boys. Right, files, jobs. It was Prey 3, wasn't it? Yes. The spindle is always in the center with a VMC. Yes, you're correct. You are correcto mundo. Well, I was thinking something similar to an L bracket, just bigger, chunkier, and not exactly an L, but more like close to a triangle. Yeah, they're called trusses. I think they're called trusses. And go onto the mod showcase channel and look up Bright, BW Wright. And he's one of the team members, and he has trusses. They work pretty well. I will say 3 flute finishes are just amazing. They're so good. It's going to take a little bit of time just to get to the same depth that it was on before. So it's going to do a little bit of air cutting for now. charge. My mic ran out of charge. I got a spare one though. It is nearly midnight where I am. It's nearly midnight. I'll probably do the chamfer. I'll probably finish the chamfer, but I'll leave the other side till tomorrow. Whilst that's working, I want some suggestions from you folks. I want some suggestions for projects that aren't necessarily Milo related, but that can be done on Milo. Stuff that you would like to see. Because doing the streams and things is nice, but I would still like to get this to a point where I'm earning some money for the project and for myself, and essentially enough money that I can survive on it and do this full time. And unfortunately, YouTube doesn't like build content unless you have a big enough stream. Like if you're a Nero-sized stream, it's great. But I would like to do some actual project-y stuff. Or would like to build some stupid shit or some cool shit or stuff like that. So any suggestions would really help, because I am a mechanical dude. I am mechanically minded, but I am not like dumb, fun, toy stuff minded. So if anyone has some suggestions, stick it in chat. And before anyone says it, no pews. I will get arrested in the UK if I do pews. Model Steam Engine. I need broader appeal. Like Model Steam Engine is they're cool projects, but they're, in all honesty, and I mean no offense by this, it's for old people. It's for old people and machinists. I need something that has appeal across YouTube. Some think more along the lines of like Zyla Foxlin and the guy who makes like 15 different bands a year and stuff like that. Or a product I wouldn't mind developing. Something that's helpful. I'd like to try some climbing gear, but obviously don't ever use the climbing gear other than for testing when you're actually backed up with someone else and something else. Oh, 3 flute wall finishes. They're so good. They're so good. They look amazing. They are a proper mirror finish. Oh. Make your own boron parts. It's not a bad idea. Keyboard or laptop case? Ooh. Ooh. Do a keyboard. Could be down for a keyboard. I probably wouldn't do it from scratch though. I'd probably just do a casing. Maybe some drone stuff. I need to learn some more about drones. Not saying it's a no, but I need to learn more about drones. I have no idea how the hobby drone stuff works. Oh, it's so sexy. Sorry. That wall finish is just fucking amazing. So in this operation, in this specific contour, I'm not reaching the chip load that I want, but I'm doing that on purpose because if you can get for finishing passes where you got taking a really, really small cut, and you want the best surface finish ever, you want to run it below chip load, below the minimum chip load that you're looking for. Well, I'm not an expert either, but I know it has a battery and some spinny parts to make it spin up in the sky. Hey, if there's anything I know about, it's spinny things. Oh, that's so. I miss 3-flute. I miss 3-flute tooling. I miss 3-flute tooling. The quality you get from 3-flute tooling versus single flute tooling is exceptional. It is exceptional. My goodness. I would take that camera, but it's not got a long enough lead. Hopefully you guys can see this. Hopefully you guys can see this. It's a bit too reflective for you, but just along here, I can genuinely like make out the grooves of my fingertips in the reflection. So good. Right, I need to now I need to load up the final contour and change the tool. Right, so that contour, I also need to post-process that. Let's pray for. I don't need to change the WCS. Post that, and then I'm going to get my chamfer mill out. These LDO chamfer mills are actually really good. They're really good. They're 2-flute. Where's my wrench? There they are. No! Is it damaged? No, it's not damaged. Parts it's ice cold still. Absolutely ice cold. So our chip load, you know your chip load is good when you can touch the part that's not even warm. Go on there. All right. In future, I probably won't use the 8mm 3-flutes very much, just because of the issues we have with full slotting. Obviously, you probably wouldn't get close to that if you're doing like a 40% step over, but I'll probably stick to the 6mm ones in future. Unless I move over to lead screws, which I might do. I might still move over to lead screws. If I move over to lead screws, then I'll bring the big chunky boy back out. But again, that's what this whole type of thing is for. It's for experimenting with and playing with. You're not always going to get things right the first time. Make a Minecraft dog blocky and easy. Also, Minecraft equals 100,000 views. Yeah. Yeah, that would be expensive though. I was thinking of like a fingerboard, not the skateboard fingerboard. It's like a climbing fingerboard. I'll show you what a climbing fingerboard. Something like this. So these are climbing fingerboards. They're used for like grip training. So something like that would be cool to make. I was once a climbing nerd. I still am, kind of. I won't need the fan on this one. Probably not. Although, if I'm going for the best surface finish, I might as well put it on. Oh, Sion, if you're still here, it's a combination of friction that keeps the fan on, and obviously the uplift from the air that's being pushed down. I have a load of them printed out and ready to go. The moment I don't feel like it's gonna hold on, like it's losing friction, I throw it away and I've got a new one out. It's not worth them exploding on you. Oh, failed to home. Oh. Alright, this is going to be the last operation we do for the night. Last operation, and then bedtime. Because it is 9 minutes to midnight. Wait, the stream is actually still going by the time I get off work once. Oh, damn it. We're still gonna go for a few more minutes. But not for very much longer. Literally the last operation. Make a palette change system so I can run 24 hours. Yeah, I mean, it's a possibility. Cool. So we have, well, a one-side finished part. Now, the way I tend to get the superglued parts down, but off, is I tend to use just a little bit of WD-40 on one side of the part. And I soak the, I basically leave it for a few minutes and it will soak all the, ooh, sorry brisket. It'll soak into the masking tape, and the masking tape, that soak will then dissolve the cyanoacrylate. Hey buddy, hey buddy. Are you milling on V2 or did you finish the V1.6? So that's we're milling the last part for V1.6 on V2. We still have one set of operations to finish. We might do them tomorrow on stream. We've got to do the other side, so. But I'm gonna call it a night for now. So hopefully we can rip this part off now. Yeah, need a little bit of leverage. It is breaking free. I need a screwdriver or something. Screwdriver. There we go. Just a little bit of force now. We can take all that masking tape off. So, and I can show you the progress. Night, Carl. Coral. Coral. Night, Coral. Right. So, let's get... Ooh, sorry, buddy. I'm stepping all over you. Not that one. What? Why you no work? There we go. So there's a little bit of membrane that's left over that we didn't cut all the way through, and that's fine because we just didn't program it. That will come off during... Go on, focus, you phone. Right. There's that little bit there. So that will come off during the facing up on the other side. So that's just a little thin bit that wasn't cut. But that right there is a decent looking part. Woohoo! Let's check sizing. Now I haven't calibrated steps per millimeter on this machine, so don't take this sizing as a demonstration of the accuracy of Milo, because I just haven't had the time to tune the steps per millimeter. But we will still check it regardless. You can only really check it in one direction now. So nominal is 120. And I'm reading I'll do both sides just to double check. 120.08. 120.08 is nominal. Sorry, 120 is nominal. We're getting 120.08 And for an untuned machine, that's not bad. That's not bad. That's not bad at all. Perfect. So, I'm going to call it there for the night, guys. It is late. It's nearly midnight over here. I hope you guys all have a fantastic day. The rest of your day, for those of you who are still awake. And I'll catch you maybe tomorrow. I might finish this piece off by myself and then do the final install of V1.6 with you guys. All right. Hope you all have a great night. I'll catch you later. Bye now.